I am going to start by putting my name on this. Put your hour in there, 2, 3, 7, whatever it is. We are beginning this packet today and this week, which means we're going to have a week break, and then we're going to come back and review and finish the packet when we get back. But this first stuff, I think, is fairly, I don't want to say easy, but I think you'll catch on pretty quickly, okay? All right, so parallel lines. The definition. Hopefully yesterday's boom decks were very review. I know some of them at the end maybe got a little bit tricky because they were starting to ask you maybe even about I'm looking 7th grades right now. They're starting to ask you about parallel lines even. But here's the definition of parallel lines. They are lines that never intersect. Lines that never intersect. You good? So algebraically, how do we know if two lines are parallel? They have the same slope. So if two lines have the same slope, we can conclude that they are what? Parallel. So here's a couple examples. Y equals 2x plus 1 and y equals 2x minus 7. Do you see how their slopes are the same? So those two lines would be parallel. The only thing different is that their y-intercepts are different. So they're both have a rise and run of 2/1. So up 2/1, up 2/1. One starting at the y-axis at 1 and one starting at the y-axis at -7. So can you visualize that a little bit? But that, if we can figure out the slope, we can decide if they're parallel, right? Now perpendicular are lines that intersect at 90-degree angles. So our axes, our x and y axis, are perpendicular lines. So this angle right here is 90 degrees. It's a square angle. In fact, all of these angles would be 90 degrees. Algebraically, how do we know that they're perpendicular? This one might get you a little bit. They have negative, or in other words, opposite reciprocal slopes. So their slopes are the opposite reciprocals of each other. Hopefully we're pretty good at the opposite, right? If something's positive, the opposite of that is negative. If something's negative, the opposite of that is positive. So we've got that part down. Reciprocals, we have to think back to dividing fractions. When we divide fractions, remember we keep, change, flip. We multiply by the reciprocal. So we've got to flip the number 2. So here are examples for that. So if y is equal to 2x plus 1, notice this slope is 2. What's the opposite of 2? Negative 2. And if you think about 2 as a fraction, 2 over 1, what's the reciprocal of that? It gets flipped. So the 1 is going to go on top and the 2 is going to go on the bottom. So we have y equals negative 1/2 x. And it doesn't really matter what our y-intercept is. It could be 0, it could be 5, it could be anything. But if our slopes, if they're the opposite reciprocals of each other, these two are parallel. Parallel. They're not parallel, they're what? Perpendicular. So perpendicular is opposite reciprocals, parallel, they are the same. Okay? So let's practice a little bit with negative reciprocals. So a fraction flipped and the signs are switched. A fraction flipped and the signs are switched. So let's think through these examples. Instead of 3 over 4, if we flip that fraction, it becomes what? What's on the top now? 4 over what? 3. So that's the fraction flipped. What's the opposite of that? Negative. So the sign gets switched to negative. 2. This is what we looked at here. What's the opposite reciprocal of 2? Negative 1/2. What's the opposite reciprocal of negative 7/8? Excellent. How about 1? Good. It's negative 1. That one's funny, right? Because 1 we would write as 1 over 1. So even if we flipped it, it would still be 1 over 1. So that one is really just the opposite. But 1 and negative 1 aren't just the opposite of each other. They're also opposite reciprocals. So obviously that's not a good example for these because you don't see it getting flipped. But it is an important one to note. Okay. Think about 0. It's not 0. So the slope of the x-axis would be 0, right? Not negative 0. There's not negative or positive 0. But if you think about this, even though it wouldn't be right, when we have a slope, we would say its rise, good. Its rise is 0. Its run is any number. But if we flip that so that it was number divided by 0, well, this, you're right, would be undefined. So if we have a horizontal line, perpendicular to that would be a vertical line, which we know or should know is undefined. questions on page 1? Does that make sense? We've got parallel and perpendicular, so nothing too tricky yet, hopefully. So on page 2, we're just determining whether they're parallel, perpendicular, or neither. Some might say they just intersect, but not perpendicular. All right, so how about 3 over 11? Is this the same? Nope. Is it the opposite reciprocal? Yes, so this is perpendicular. How about number 2? Are these the same? Yes, so that tells us they are parallel. How about number 3? Are they the same? Nope. Are they opposite reciprocals? Nope, so they are neither. I think this time last year we were all having the debate of whether it was neither or neither. You can say it either way. Or either way. All right, how about 4 and 1/4? Are they the same? No. Are they opposite reciprocals? No. They're reciprocals, but they're not opposite. Their signs are the same. So these are also neither. Are these the same? No. Are they opposite reciprocals? No, they're just reciprocals. So we call them or neither. How about number 6? Are these the same? Nope. Are they opposite reciprocals? No, they're just reciprocals. They're not opposite. So they are also. How about this one? Just reciprocal, not the opposite, right? How about number 8?
That's not true, actually.
They're not the same, but they are opposite reciprocals, right? This would be like 7 over 1. They took the opposite of this and they flipped it. So this would be what? Perpendicular. How about number 9? These are the same, so they have to be parallel. And number 10 is what? Neither. Because they are the opposite, but they are not reciprocals. And they're not the same because they're the opposite. All right, questions on page 2. Excellent. Let's look at page 3 together. Are you ready? We have to figure out our slopes. So we're going to use our slope formulas. Remember, our slope formula is, our slope is y2 minus y1 all over x2 minus x1. So I'm going to say 6 minus 3 all over 2 minus a negative 2. So be careful with that one because those are going to become plus. What's 6 minus 3? 3. What is 2 plus 2? 4. So now we just need to find the slope of CD. So the slope of CD is equal to 3 minus 0. That's our change in y. And 3 minus a negative 1. So careful there. Becomes a plus plus. What's 3 minus 0? 3. 3 plus 1 is 4. So are these segments parallel, perpendicular, or neither? They look the same to me, so I would call them parallel. Now, am I expecting you to show this work? Absolutely. You should be practicing your slope formula. It's very important. Not just writing down your slopes, Not just writing down parallel, but showing how we found the slopes, right? All right, here our slope of AB is equal to, so 4 minus what? 4 minus 2. Remember y2 minus y1. And 5 minus what? 0. Now we just have to do that. What's 4 minus 2? And what's 5 minus 0? We've got one slope. Now we need to find the slope of segment CD. So 3 minus what? 8. All over 3 minus 1. What's 3 minus 8? Negative 5. What's 3 minus 1? 2. Are these parallel? No, they're not the same. Are they perpendicular? Yes, they are. They're opposite reciprocals. All right, so my slope of AB and my slope of CD. So I have, remember I'm starting with my second y value, 6 minus my first y value. What's my first y value? 8. Our change in y is always on top. Our change in x is our second x value minus our second y value. So be careful there because we switch. What's 6 minus 8? Negative 2, be careful. And 2 plus 1 is 3. My second y value for CD is 3 minus my first y value all over my second x value minus my first x value. So be careful here because we have to switch on the bottom. 3 minus 2 is 1. 3 plus 1 is 4. Are these the same? No. Are they opposite reciprocal? No. So we're going to say neither. Or you might say they're intersecting. They're just intersecting lines. They don't intersect at a 90-degree angle, so we can't say they're perpendicular. But they do intersect, so they're not parallel either. All right, so our slope of AB and our slope of CD. You guys should get really good at this slope formula. Our second y value minus our first y value all over our second x value minus our first x value. What's 4 minus 3? What's negative 1 minus 2? Negative 3. So negative 1/3 is our first slope. Here we have our second y value is 6 minus our first is 3 all over our second x, which is negative 4, minus our first x, which is negative 5. So be very careful and remember that you have to switch when we have two negatives and we're combining them. 6 minus 3 is 3. Negative 4 plus 5 is 1. So this way it's very easy to see that these are what? They're the opposite and they're flipped. So they're opposite reciprocals. So we call that perpendicular. So here we have the slope of AB and our slope of CD. our second y minus our first y. Uh-oh, what's going to happen here? And our first x minus our second x minus our first x. Sorry, I misspoke, but they happen to be the same this time. So we really have 9 over 0, which is what? Undefined. Undefined. All right. Now on top, I notice our y doesn't change. So that means we have -5 minus a -5, which is really what on top? 0. And here we have 6 minus 3. It didn't really matter what the bottom was, though, because 0 out of anything is simply 0. So what did we learn about the slopes 0 and undefined? They are opposite reciprocals of each other. Remember, this is undefined. You fall off the cliff, right? And this is 0 fun. So these two lines intersect at 90-degree angles, and they are perpendicular. Okay? So, do you want me to keep going? You want to practice these last 3? Practice these last 3. Tomorrow we will practice some more and then learn something a little new. It's not much new. No, it's still the same thing. You're just taking it out of the equations is all. Actually, probably easier than using the slope formula. Okay, so practice these last 3 today. Okay. And then tomorrow we'll practice that a little bit more and continue to use that whole parallel versus perpendicular ideas, okay? You won't be needing your math workbooks for the remainder of the week. So, and even when that first day we come back from break, we'll still be in this packet. So not until after we have a quiz over this material. I super appreciate those of you who brought it with you today and were prepared with that, your Chromebook and a pencil. Keep it up.